So hi everybody, thank you for coming to our talk, really appreciate that. So I think we have tons of material to pass and also a lot of demos, so we'll start going fast. So chaos debugging. So first of all, before we kind of start it, let's frame the problem. Why are we all here? So the reason we're here is because it's really hard to debug a distributed application, right? So that's kind of like understand why. So back in the day, when we all was writing a monolithic application, that was pretty simple for us to just attach a debugger and see what's going on with the application. The stage was kind of like located in one place, in one binary. You could just basically attach the debugger and see everything that's going on in the stage of the application. Well, that's not the case anymore, right? Because we kind of like right now took this big, huge binary and cut it into really, really small microservices, which means that now you have a lot of microservices, and the state is spread all over around. So there is no way for me to actually get the whole view of the actual application. So in this presentation, I have in this slide I have what six microservices. It actually looks like this, right? I mean, there's way more than 6, right? So we're looking at 500 plus in Netflix and the others, and because it's so easy, there's more and more and more. And the thing is that now, it's so complicated to actually solve this problem. So this is a tweet that I would like to share in my presentation. That's actually not that deep as this guy is. But it's actually true, right? I mean, this is what's going on. So when we looked at that, we wanted to solve this problem. And that's why we came with something really important called Squash, which is all open source. Basically trying to bring the regular debugger experience in monolithic application all the way to microservices. So now, which will show you that.
So we'll demonstrate Squash's capabilities with a very simple microservice app. Here we have a very basic calculator. It adds and subtracts. However, there's a bug. 2 plus 4 is not negative 2.
So let's see what's going on with Squash. This app is composed of a Go representation service. It does the
rendering and a Java sort of backend that does the computation. And they speak with each other. Right now they're running in Kubernetes. Let's use Squash to connect to them. So service 1 is in the cloud namespace. It is the first container here. It's Go app, so we'll use TLP to debug it. Right now, Squash is creating a pod that has the ability to connect to our running process. And now you see we have a debugger attached. Really just like we would have attached locally. And now we can set breakpoints. Let's set one here as the enter function. And let's do the same thing in our Java app. Use Squash. It's in the cloud namespace, but this is service 2, and we use the Java debugger. Squash is doing the same thing right now. It's negotiated a connection with the running process. And we can set a breakpoint. How about right here? Now we'll go and create some traffic and see if we hit these breakpoints. I'll change the values just for reference.
And just like that, the debugger took control of my screen as it got activated. And we can step right through it and inspect variables just like we would in a local developer debugger. So we've got 2 here and 5 just like we specified. Looking ahead, I see that we're about to call our backend service. So let's set a breakpoint just on the other side of that. And let's go ahead and let it run. The code is executing, and it's flowing now over to the backend. And we should hit that other breakpoint. Oh, there it is. OK. So yeah, let's step through it again. And looking in the Java process here, we can inspect the state. We see again that the value is, let's see. I think we're dealing with a little bit of latency, but you can inspect the variables here as well. So here's 2, just like we saw before. And let's let it run again. Execution flows back to the front end. But let's jump back and see our app. The code still hasn't propagated forward, but I'll just release that, let it run through. And there you go. That's the process has continued to flow. But now that we've seen where the code is going, we have a better idea of what the issue might be. And it looks over here like we're actually subtracting when we should be adding. So let's go ahead and patch a fix for that. I anticipated this bug, so I had this container ready. And let's just verify. Oh, we don't need these anymore. I'll exit the debugger. And reload. 2 plus 5 is 7. OK, cool. So we solved the bug with squash.
Yeah. So let's understand what just happened here. Can you bring it back? OK. So let's understand what just happened here. So basically, what is squash? Because I don't know if it was clear, so let us explain that first. So first of all, squash is a debugger orchestration. OK? So in the end of the day, what we did here, we took all those, squash easily show me all the pod that running in my cluster. They show all the container in the pod that I chose, and then I could actually attach whatever debugger I wanted. So what Squash is actually doing here is doing all the piping, right? Because it's kind of like a complicated problem to start attach them to each. Now you can attach the Java debugger to the Java microservices, the Go debugger to the Go to the DLV to the Go microservices, and just basically run and walk through your code. Because it's a debugger, you can just change it in memory and so on. So it's kind of like a very easy, simple experience. Now, in Squash itself, there is 2 modes. The first one is the default one. That's basically a CLI, right? I mean, there's no really more than this. It's not doing more than this, and I will explain in a second. And the second one is the secure mode. So let's look a little bit of how it's executing. So in the end of the day, I have a node. I have namespace of my application. And what I also have is a namespace of Squash. In the default version, it's pretty simple. I'm just attaching, basically deploy the debugger, in that case DLV, because I'm debugging Go, and just attach it to the running microservices, a running process, basically. But the problem that I really have is to understand to which process I should actually attach in the namespace of the operating system PID. And that's basically the magic of Squash. What we're doing is we're trying to do the piping, but if we are on the host level, the PID is not, we don't know what is the PID of actually this process. So we're doing some game here. What are we doing? We're basically going to create the create object of Kubernetes and actually running a command inside the container of the microservices, the application itself. What we're doing there is basically looking for the namespace and the inode that is unique to this specific process. So now we know which process on the host level we should actually connect to. And then we're just connecting it. Now, in the secure option, it's a little bit different because I want to make sure, so if I'm running locally in my kube, a mini kube, I don't care, I can actually debug everything. But if it's a shared cluster, you probably don't want people to start actually debugging your processes. And for that, what we need to make sure is that they have a permission to do that. And that's pretty simple. What we're doing is, first of all, now we need a server, right? Because something needs to watch something. It's not a CLI kind of like experience anymore. The second thing that we're doing, we basically, when you actually ask for us to actually debug the microservices, we're putting an intent CRD in the namespace of the application. Now, if it works, it means you have permission. If you have permission, we're letting you go ahead and do it. If not, you will not be able to actually debug these microservices. And then it's really simple, right? The same thing, we realize what is the PID, we spinning up the debugger and attaching it. So it's pretty simple. So Squash is open source. It's actually really, really cool. You should go and try it. Look, we are solo doing service meshes, distributed system, API gateway, all our product. The reason we actually released that is because we're using it internally constantly. This is why we build it for ourselves. So I really, really recommend you just go ahead and use it. It's open source and it's free. But that brings us to the next question. This is great, but can we actually doing it in production? And the answer, of course not. Who will be crazy enough to actually attach a debugger to a running process in production? No one. Don't do that, right? So now the question is, what can we do about it? So let's look at the simple request that coming to the cluster, right? I have pod, I have cluster. Request is coming, it's going for all those microservices, going maybe to a database, going maybe to S3, continue. That's great. But I want to know what's going on there. So what are we doing? We need logs, right? We are never debugging anything anymore. It's all about troubleshooting. So you need the logs, but here's the problem that you have. There is a lot of logs, right? There's a lot of production running. They're all spread around. How do you do that? So because they were spread around, this problem is already fixed, right? It's called it was calling open tracing, then open consensus, not open telemetry. But this is a tracing system. That's simple. The problem that we have with that is that there is a lot of logs, and you can't start flying logs over your network. It will kill it. So what should we do? So that's the real problem that we have with open tracing. And open tracing or open telemetry now. What they're doing is they basically have two ways to actually go about fixing it. Number one, they're only taking the headers. That's all. So the body is something that you're not getting. The second thing is that the sampling. Sampling is the most important word in the open telemetry world. You can't take everything. So now you need to figure out what you can take, and you're missing some stuff, right? I mean, it is what it is. It's a trade-off in the end of the day. And seriously, if you think about the challenge of using open tracing, that's the challenge, sampling. Which one to sample, how much to sample, it's an art. You don't want it to swamp your network. You don't want not to get the data. It's kind of like a pop. OK, so that's that. That's great. So now, service mesh. I'm a big fan. This is what we're working on all the time. This technology has come about to actually help us, right? Today, when you're actually using STL, maybe, I think the Linkerd, yes, maybe. You basically get, yes, Linkerd as well. You're basically getting all this open tracing and stuff out of the box. It's already wired, and it's great, because they want to give you observability. It's all about observability and security. So that's great, right? We look exactly the same thing. Right now, instead of actually going directly to the application, it's always going to go through a sidecar, right? So basically, and the sidecar is a proxy, and this proxy, in most of the cases, is Envoy, and sometimes it's Linkerd proxy, right? So that's the idea. That's great, but again, it's not solving me any real problem, right? I still need to put it in OpenTelemetry. And if you think about it, what I need to do is still have the same problem of I need to sample. I can't get it all, right? By the way, it's logging. You need to log it in your application. You need to import the library. There's quite a lot of mess around that. OK, so we looked at it, and as we said, we're working service mesh for 2 years, right? The announcement of SMI, it was basically our announcement together with Microsoft. So, we're very passionate about this space. And we said, look, service mesh is great. It's solving 3 different problems, right? Today, routing, right? That's the first one. The second thing is MTLS, security policy. That's, to be able to actually, the microservice to security commute to each other. And the last one is basically observability. But the question is that all it can do? And no, that's basically why our company exists, because we believe that the interesting stuff will come on top of those meshes. That's why SMI is so important. OK, so let's look at what we can do. So do we really need all the data? Do I really want all the log that exists in the system? In my opinion, we don't. I mean, think about it. Do I care of the one that actually was successful? Maybe for auditing, but I don't really care, right? It's a successful transaction. So what if I will be able to actually solve this big data problem by actually taking only what I really care of? So let's do this. So what basically, we're working with Lyft, actually, and we extended the top filter that Matt Klein did. We're working together, actually, because that's something that they need internally, so we're building that for them. And what we're doing, we basically came with this decision of what if we can actually record everything that happened in your request. Now, we're buffering, we're not taking it out of the node. Now, in the end of this request, if everything is good, I really do not care about this information. So I'm not going to do anything with it. I'm going to toss it. But if, for some strange reason, there is something wrong and we will talk about what wrong means. Then I want to save it. That's the data that I want. And now I will send it on the enter. But I will be able to do the body and the header. And I will be able to do, by the way, because of the service mesh, everything that's happening inside my application, even if my application is went to a database or to S3 and bring me the data back. I'm getting the snapshot of what I got back, which is huge, right? It's exactly snapping the data on your production, which I think is great. And we're calling it loop, right? Loop, because we think that what's special about loop is the ability to actually replay these things after it. And that's what we're doing. Now, Lyft has a little bit different use case, and I will share that with you. What Lyft is doing is basically they have their system, and this system is, someone calling because, I don't know, they're not managing to order a Lyft. And what they're doing, they're basically calling to this support system, and they have a support system, and they wanted to be able to actually click a button and record everything that's related to this user. So that's basically what we're building for them. And then their engineer can go and actually explore it. So basically, if you think about what we just did, we recorded all your problem in production, including the data that are running in the pipe. Now we can just respin it, right? And attach Squash to each of them and just replay your problem in production with all the data that you had when the problem happened, which I personally think that it's huge. So, let me show you a demo now.
So we just fixed that calculator app, but apparently we introduced a new bug. And I don't know what it is, so I'm just going to attach loop and see if we can catch any 500s. We have loopctl, makes that easier. We can list any messages that have been found. But actually first, we need to tell loop what to look for. I've set up a filter to look for 500s. It's pretty simple. This is just a basic filter. You can do more complex things, but here it's looking for the prefix of 500 on the response code. So let's apply that. And I'll also configure Envoy to look for that. So now we've got loop ready to find any error messages. And let's see if we can reproduce the bug. Let's see. No, it looks like it's working right. Let's just keep adding some inputs. No. It's not such a bad app. Oh, there's an error, though.
Okay, good.
And what did that come from? Let's see if we captured it with loop. And we did. But we didn't capture all the other messages that we produced. So that's nice. Let's go ahead and open up Squash in a sandbox environment that is looking at that newly deployed app. And just like before, we'll attach Squash. Service 2, it's in Go this time, so we'll use DLV. That's negotiating the connection now. And we're attached. I'll create a breakpoint and go ahead and replay that traffic with our command line tool. So replay. And it caught in the debugger, as we'd hope. Let's jump forward, see what's going on. I think there might be something in compute sum. So let's play through. And we're down there. And again, we can inspect the values. And it's actually with the inputs that produce the error. So I find that really helpful. Let's step into compute sum. Scroll down. OK, it looks like it's doing the math correctly. Oh, but I think somebody put an Easter egg in here. Anytime the sum is between 500 and 600, it produces a 500. OK, so that's the bug.
OK, give me back.
All right.
OK, so we're really passionate about it. We think it's great. It's going to be open source very, very soon. The reason it's not open source yet is because we were on the tab filter. We want to put it upstream Envoy, because that way we're basically getting it in every service mesh that using Envoy, and it was very, very important to us that you will be able to seamlessly work with this, with SDO and App Mesh, with Console Connect, and so on. So now it's bringing us to this question. That's great. So if there is a bug, we can actually fix it. Can we proactive prevent bugs? And this is a good question, right? And this is exactly what chaos engineering is all about. So think about it like a vaccine, right? I mean, in the end of the day, when you're going and taking a flu shot, right? Why are you doing this? Because you can actually inject something to your body that will be actually dealt with and, basically basically mimic, if you want, an attack on your body, but you controlling how strong the attack is. And therefore, when the attack is coming, your body already knows how to deal with it. So that's basically the idea. This is all about chaos engineering. Imagine it's really, really simple. So now, it's all about a control experiment. We actually will be able to actually go to a production system, try to attack it when we feel comfortable with it. When it's actually something that we know is that we can monitor, we can log at metrics and make sure that we're not killing all the environment production, we can actually make our application really, really resilient when it's actually running on production. So I'm going to show you real quick about the two problems that today exist. So chaos engineering is not a new thing, right? I mean, it exists, it's there, there's companies working on it, Netflix introduced that, and so on. But there is two things in today's system that you have to do in order to actually using it. And the first one, you need a library, right? Like everything, we need a library. If we need a library, it means that it's only going to work with a specific language, which is pretty annoying if you're using something that does not exist. The second thing, it means that you need to modify the code. If you actually want to import a library, now you just detach, and this is exactly what Service Mesh is trying to prevent. You just detach the actually configuration or management or whatever you want to call it with the business application log. If the library, you need to upgrade, whatever, because the provider upgrade, you need to redeploy the microservices and so on. Not really healthy experience. But now we have Service Mesh, right? What did we do with Service Mesh? We have a cluster, we had microservices. We somehow managed to abstract the network on every traffic that coming node to start. That's exactly what API Gateway is doing, right? We have Gloo, but there is a lot of out there. And the second thing is that we also need some Service Mesh, right, to take care of all the east-west traffic. Right? That's basically what we're doing. So in the end of the day, every time that a traffic coming to the cluster, it's going through this proxy that the API gateway or the ingress is representing, and every time that the traffic going across, between microservices in the cluster already, they're going to go to the sidecar that your microservice is using. Now, why it's important? It's important because the proxy configuration that you're giving to a sidecar should not be like the one you're giving on the edge. It's different, right? I mean, maybe it should be more secure, maybe rate limiting interesting in the edge, but I don't care inside the cluster and so on. Okay, so now, when we actually abstracted the network, we can actually inject on that level. So we don't need to change your application. You can just inject fault and latency on the proxy level. And now you can actually do chaos engineering on the proxy level. You are not changing your application. You don't care which language it is. It's just going to work. And we're really passionate about that. So again, it's all about the control experiment eventually. I mean, you need to schedule, usually what people are doing today, they are scheduling an experiment that's going, I don't know, every Friday at 9, let's say. And then what you need to do is to watch the actual metrics to make sure that you're not taking all your system down, right? You want to make it control, like an experiment that you can actually control the result and not taking all your system down. And that way, you basically that's exactly what's going to happen. If it's going to a threshold that it's taking, that you define that it's too warning your system, the experiment will stop. And that's the beautiful. That's all about the control. So we introduced Gloo Shot. Gloo Shot is basically a chaos engineering on top of any service mesh. We will talk about that, but it's all on service mesh because of the SMI announcement that we made 2 days ago, right? We make Microsoft together and Ashi and Boyan. It's very, very important to us to build stuff and extend the ability of service mesh on the level of the stuff coming on top of it. So again, it's pretty simple, right? You can create an experiment. You can say which services you want to inject a message delay and network is already going and watching actively. You don't need to do anything. Your Prometheus and metrics, and you know when to stop when it's dangerous to your system. And you can just repeatedly running it and schedule that, and it just works. Now we'll show you a quick demo, and then I will show you something even cooler.
To demonstrate Gloo Shot, we'll use Istio's book info app. Just a quick overview on that. We have a product page. It's the sort of the landing page, and it's aggregating data from a few different services. We have this review service that calls out to a rating service. But we want to know what happens to our system if there is a fault in the ratings. What if the ratings service is not available? So let's set that up with an experiment. I've got one set up here. So we'll set up a fault so that that service, the rating service here, will become unavailable. And we'll let that run until we see a certain number of, or a certain rate of error messages coming out of the reviews, just so we don't do too much damage. All right. Let's just verify that the service is working before we put in the chaos experiment. So I'll connect to it. And we've got Grafana for reference. So here's the landing page. And from that diagram, you see we've got the reviews content over here, and then ratings. And yep, the app is loading fine as I reload it. The Grafana metrics will populate in a time cycle. So that's looking good. Let's apply the experiment and see what happens. OK, so that's live. And oh no, we lost all of our content from the reviews, not just the ratings. So that's a vulnerability. But notice that as I continued to refresh the page, we triggered more and more failures, and we met our Prometheus thresholds to terminate the experiment before it caused too much damage. And you see the rise of 500s triggered the cancellation of that experiment. And if we continue to reload this page, it'll just be 200s going forward. Now, we can deploy a more resilient version of that app, reapply the experiment, and see what happens. So let's set that up. We're using superglue to help us configure Istio. And let's see. OK, so we should have our more resilient app deployed now. And this time we'll apply a repeat experiment. But since we don't expect it to meet the failure threshold, we'll include a timeout. It will time out after 30 seconds of this. But we reload, and in our more resilient application, the reviews content still shows up, even though we're missing that ratings data. This is preferred behavior. Refreshing, not getting any more 500s, because the 500 metric is measured between the reviews and the product page. And the review service has not produced a cascading failure when it was lacking the ratings data. Continuing to review, and we see that it timed out on a timeout basis. And this means the experiment succeeded. Our app is now more resilient. So.
OK, cool. So again, Gloo Shot is open source. Go have fun. Okay. Now the question is, how is the best way to start with all those projects? So yesterday, the day before yesterday, sorry, we announced the SMI, the Service Mesh Interface. This is the ability to actually unify all the Service Mesh functionality in a very simple API. And it will be shared between every provider. The fact that we managed to bring all those community around with us and the great Microsoft to stand behind it, has pushed that, it's great for us, for all the community and all the innovation that will come on top of it. So let me show you what we built on the last year and what we, when we came with this SMI and what we think that should be done to start with those applications. So I will show you, we announced last week something called Service Mesh Hub. Service Mesh Hub is the ability to play with Service Mesh, right? If you want Service Mesh, that's the place for you. And as you can see, I already have 2 meshes installed, 1 app mesh and one linker D. And what you can see is that I can easily install another one. It's pretty simple. I'm just giving it a name. I'm actually basically just choosing the namespace that I want to deploy in, which version I want of STO, and I'm just clicking it, right? It's pretty simple, the installation of STO. What you can see is that in a second, STO is being installed, and what you can see that we also discover every services that running and managed by this STO. So you can see it's discovered. And now what we can do is actually go and extend it, because Service Mesh is all about the functionality of that this technology is giving us. But you can see there's quite a lot out there already, Flagger, Key Alley, and also everything that we did. And you can basically, like an app store, just go Android store, just click and download it to your mesh. Now it's smart, because you know everything about your mesh. You know everything about the Prometheus that you're using. If you have security, he knows what you can and cannot install on your mesh, and it's just going to go ahead and install it. So this is a very simple example. It's Key Alley, right? Coming from the Reddit Fox. We'll do the same thing with Loop, right? It's pretty simple. Just go ahead. It's an application. It's extending. It's going to work seamlessly. Now it's there. It's free. Just servicemeshhub.io. Go play with that. So we'll finish in a second, but what you can see is that it's pretty straightforward and simple. Maybe you trust me, because I don't think we have time. So again, Service Mesh Hub, go play with it, .io, go play with it, free, awesome, have fun. Now I will see if I can actually move next to my presentation.
Space bar?
No, it's not going to work. Okie dokie, now it's good. Okay. No, it's not. So let's go out. Sorry about that, guys. It will take a second, but we are finishing. So we're going to summarize right now. Where is the mouse? Okay.
Chaos.
Yeah. So let's once again summarize what you saw today. So that was a very short session, 35 minutes, and look how much we actually did. So we talked about Squash, open source, go try it. Seriously, no relation to Service Mesh. This is how we develop our application. Go ahead and try that. Open source, again, free. We are on the Slack. Come ask us questions if there is any problem, but it should be so simple. Now Loop, coming up soon with the Lyft guys. Again, very simple. It will be open source, so go fix it. Go and basically capture the problem that you have in production. The last one is Gloo Shot. Gloo Shot is a chaos engineering, already open source. Go make your application a little bit more resilient. And the Service Mesh Hub, again, also free. Just go and play with meshes. We have more products. I would just say, if you're already there, maybe you should take a look at our Gloo, which is an API gateway, in my opinion, the best that exists in the market. CRD natively on a Kubernetes, and also, as its name, it's gluing those environments of monolithic microservices and serverless. Scoop is a GraphQL server built on top of Envoy, as well as Gloo, by the way, built on top of Envoy. And SuperGlue is basically the SMI. It's basically SMI with discovery and the ability to group meshes together and treat them as one big mesh, flooding the networking across them. Go try it. It's really cool. And that's it. That's all we have. So we are solo. We are in Cambridge. We are hiring. Cambridge, Massachusetts, we are hiring. Go look at our hub. There's a lot of stuff open source there. I think you will benefit from it. I'm Idit, this is Mitch. Follow us on Twitter, and go build very resilient application. Thanks so much.
Thank you.